Hello, this is Angelia, and you are listening to or watching the podcast Why You Do What You Do. Podcast that talks about human development and psychology to help you figure out maybe a little bit more of why you do what you do. And we left off talking about the brain. You know, we all have one. Some people use it, some people don't, but we were talking about the different parts of the brain. So we're going to move on from there. Integration, process by which neurons coordinate the activities of muscle groups. Because your brain controls all of your muscles. Every time you do something, your brain told your muscles to do that. You know, like me situating in the chair, my brain told my muscles to do that. We want to move this way a little bit, so that's what we did. Differentiation, process by which neurons acquire specialized structure and function. So that would be if you went into a certain field, you like became an athlete, or if you were, a seamstress or whatever, your brain would learn specific things and your muscles would get more specialized, and your brain would too by doing these specific things. So our brain not only can just do basic stuff, it can do specialized things, depending on what we basically needed to do. Through integration, the neurons that control various groups of muscles coordinate their activities. Through differentiation, each neuron takes on a specific, specialized structure and function. Growth of neural connections during the first 2 years of life. The rapid increase in the brain's density and weight is due largely to the formation of dendrites, extensions of nerve cell bodies, and the synapses that link them. So I'm sure you've seen those pictures. You got the cell, and then you get your little dendrites, coming off of them. And the more of these you have in your brain, the heavier your brain gets. You can't look at them and see them. You have to see them under a microscope. But they add up, and they get heavy, the more you have. The mushrooming communications network sprouts in response to environmental stimulation. And so, again, stimulate those kids, talk to them, do things to help them. It makes possible impressive growth in every domain of development. So the more you talk to the kid, and I've seen people that don't even talk to the kid except to say no and yes. They don't engage the kid. They don't talk about what the kid's doing or seeing. And you're not going to have an intelligent, well-adjusted child if that's the way you're raising your child. If it's just a thing in the corner that you have to yell at every now and then. Cell death, elimination of excess brain cells to achieve more efficient functioning. And that's why sometimes we kind of lose things, forget them. Or if you're doing something and then you stop doing it for a long time, it's not always like riding a bike. You can't get right back on always. Sometimes if you haven't done that in a while, that's hard. You got to remember how to do it. So the brain kind of culls the excess, cells to make room for ones, that you're using now. But again, it still remembers you can come up to these things and do it again. This process of cell death or pruning of excess cells begins during the prenatal period and continues after birth, helping to create an efficient nervous system. And your nervous system is all about efficiency. That's what it wants. The fast, recall, the fast decision making. It is in your survival interests to have a fast acting brain. Myelination, process of coating neurons with a fatty substance, myelin, that enables faster communication between the cells. Now, that's why your brain craves fat. So for all you people who crave fat, your brain wants fat because it can make the myelin sheaths that connect the neurons and things that covers and makes for a faster transmission. So there's got to be a balance. You have to have enough fat in your diet where your body can make these myelin sheaths for, to coat these neurons and cells, but you don't need so much that you're coating the inside of your arteries with fat. So it's a balancing act. You got to learn about good fats and eat the good fats because it will still provide that, and not the bad fats, which are going to clog your arteries. So life is a balancing act. Myelination, much of the credit for improvement in efficiency and communication goes to the glial cells, which coat the neural pathways with a fatty substance called myelin. This process of myelination enables signals to travel faster and more smoothly, permitting the achievement of mature functioning. So, this is a problem for children who are undernourished. If they're not getting enough nourishment, they're not getting any fat in their diet, then they're not developing enough of this myelin to coat, and make for a faster connection through the brain. So, that's why nutrition is important, in the brain, and why most pediatricians don't worry too much about if your baby's a little chub, because they'll lose it later on, usually, unless you're just eating a horrible diet and, the kid gets fat. An embryo's brain produces many more neurons or nerve cells than it needs, then eliminates the excess. And this is because it wants to be ready. The child is learning things, having to figure things out. So having all these excess nerve cells, makes it easier for them to specialize, and then as they don't need them, the brain kind of cleans itself out, the body's like, yeah, we don't need these, let's set these, make these here for a certain thing. The surviving neurons spin out axons, the long-distance transmission lines of the nervous system, and those are the little lines you see coming out from the cells. At their ends, the axons spin out multiple branches that temporarily connect with many targets. And that's when the brain is, being connected. Like I said, your kid's basically insane when it's born. It has to make these connections in the brain. And the more connections it gets, the better it's going to be. And that's why I say you got to watch your little people, because those little toddlers don't have any common sense yet, but they have ideas. And sometimes their ideas run ahead of their common sense, and so you got to watch those little people, because they're crazy. They be doing crazy stuff. Spontaneous bursts of electrical activity strengthen some of these connections, while others, the connections that are not reinforced by activity, atrophy. And we know atrophy means to die and fall dormant. So, in other words, in the brain, as with a lot of things, if you don't use it, you lose it. After birth, the brain experiences a second growth spurt, as the axons, which send signals, and dendrites, which receive them, explode with new connections, electrical activity triggered by a flood of sensory experiences. So, again, the more experiences you give your child, the more connections they're going to make in the brain. And the more connections they make in the brain, the smarter, more well-adjusted they're going to be, right? Now you're seeing. These fine-tune the brain's circuitry, determining which connections will be retained and which will be pruned. And if you think about the brain as like a computer or an electrical system, it does have circuitry. This cell has a wire, if you want to call it that connects to this cell. And the more connections you have, like I said, the more intelligent, you're going to be, or the more athletic you're going to be, or the more, handy you're going to be. It just depends on what you are geared towards. And all that starts happening as a baby when your brain is being wired. So again, you got to give the baby experiences. You got to speak to the baby. You are programming this new little child. So if it helps, pretend it's a computer and you have to program everything into it. This means this. This is how you do this. You know, you have to program it all in. It comes as a clean slate. Knowing nothing, can't do nothing, you got to program it all in. Wiring the brain, development of neural connections before and after birth. Early reflexes. When you blink at a bright light, your eyelids are acting involuntarily. Such an automatic innate response to stimulation is called reflex behavior. Reflex behaviors are controlled by the lower brain centers that govern other things. Autonomic involuntary innate responses to stimulation are reflex behaviors. Involuntary processes such as breathing and heart rate. That's all involuntary. That's going on in the reptilian part of your brain. You don't have to think about it. It's just automatic. It just happens. Molding the brain, the role of experience. The brain growth spurt that begins at about the 3rd trimester of gestation and continues until at least the 4th year of life is important to the development of neurological functioning. Again, because the more experience, the more they hear and see and do, the more connections are being made in the brain. So, you know, if you leave the kid over there in the corner or in a playpen or in a bed or whatever, the kid's not learning anything. Oh my goodness. Itchy. So, and then if your kid grows up not to be, how to put this? Not so swift. Well, did you do everything you could? Just saying. Plasticity, modifiability, or molding of the brain through experience. That's how we learn, through experience. And this is something, you know, I talk to my kids about because my parents, of course, you know, learn from us. Don't make the same mistakes. But we all know it doesn't work that way. People learn from experience. We can tell you something 20 times a day, but if that's not in your experience, it's going to probably go in one ear and out the other. You're not going to be meh, whatever. So unfortunately, you know, we all have to have our own experience to learn from, and you know, it's a shame, but it's the way it is. Okay, we're going to talk about the early human reflexes. The Moro reflex. The baby is dropped or hears a loud noise. And that's the behavior extends legs, arms, and fingers, arches the neck and back, draws back the head. So that's when, like, as if, you know, the baby hears a noise, he goes, you know, I'm sure we've seen babies do that. You know, that's the Moro reflex. The 7th month of gestation to 3 months old is usually when that appears. The Darwinian grasping reflex. The palms of the baby's hand is stroked. And you know that when the baby grabs your finger, they do that right from the beginning, you know. So that's the Darwinian reflex. It makes strong fists can be raised to standing position if both fists are closed around a stick or your hands. Hopefully you're not just giving sticks to your baby. Some of these examples, people, come on. And then it gets 7 months to 4 months old. The tonic neck reflex. The baby is laid down on the back. It turns its head to one side, assumes a, good gosh, fencer position, extends the arms and legs on preferred side, and flexes the opposite limbs. 7th month of gestation to 5 months old. And now I had a child who had a tonic neck reflex problem, and still had that up into elementary school. And so they had a physical therapist work with him on this, because, you know, this was a problem in his classroom. He had problems sitting and being comfortable and things of this nature. The Babkin reflex, both of the baby's palms are stroked at once. The mouth opens, eyes close, neck flexes, head tilts forward. That's from birth to 3 months, and that's when the baby was, you know. So The rooting reflex, the baby's cheek or lower lip is stroked with finger or a nipple. The head turns, mouth opens, suckling movements begin from birth to 9 months. So, you know that, and the baby's is just, you put that nipple anywhere near it and it's hungry and it's like, oh, it's ready. Walking. Baby is held under its arms with bare feet touching the surface. Makes step-like motions that look like well-coordinated walking. And that's from 1 month to 4 months. Swimming. The baby is put into water face down, makes well-coordinated swimming movements from 1 month to 4 months. And these are all natural human reflexes that we have as human beings that start from the time, you're a baby. These things are programmed into you and, part of your reptilian brain because it's a reflex. It's not something you had to learn. So these are things, that we just come programmed with. That comes pre-programmed. Early sensory capacities. The developing brain enables newborn infants to make fairly good sense of what they touch, see, smell, taste, and hear. And their senses develop rapidly in the early months of life. Touch and pain. Touch is the first sense to develop. And for the first several months, it is the most mature sensory system. When the newborn's cheek is stroked near the mouth, the baby responds by trying to find a nipple. Early signs of this rooting reflex occur 2 months after conception. By 32 weeks of gestation, all bodily parts are sensitive to touch, and this sensitivity increases during the first 5 days of life. And that's to get them ready to live outside, and feed and be able to, know what they're touching, and it's just survival instincts at that point. Smell and taste. The senses of smell and taste also begin to develop in the womb. The flavors and odors of foods an expectant mother consumes may be transmitted to the fetus through the amniotic fluid. After birth, a similar transmission occurs through breast milk. They're tasting the food that you ate, and they're tasting you, basically, so they know your scent and what you taste like. And that might seem weird to you, but that's a natural thing that's in the natural world. Hearing too is functional before birth. Early recognition of voices and language heard in the womb may lay the foundation for the relationship between parents and child. And like I said, your mother's voice is the first voice you hear. You hear it from the inside out. It's a muffled sound. And then you might hear dad or brother or sister, whatever. So that voice should be a comforting, soothing voice. So try and keep your house like that. If there's strife in the house, when you're pregnant, there's probably going to be strife in the house after you have the baby. So be thinking if that's the right environment for the baby. Sight. Vision is the least developed sense at birth. The eyes of newborns are smaller than those of adults. The retinal structures are incomplete, and the optic nerve is underdeveloped. Newborns blink at bright lights. Their peripheral vision is very narrow. It more than doubles between 2 and 10 weeks of age. The ability to follow a moving target also develops rapidly in the first few months, as does color perception. So imagine, in 1 month, you can't really see, everything looks kind of fuzzy. And then, a few months later, you suddenly can see, your peripheral vision here. And then you start seeing colors and things like that. So this happens pretty quick for the baby. It doesn't know that, but for us, that would be quite the wow, shocking thing. Motor development. Babies do not have to be taught such basic motor skills as grasping, crawling, and walking. They just need room to move and freedom to see what they can do. When the central nervous system, muscles, and bones are ready, and the environment offers the right opportunities for exploration and practice, babies keep surprising the adults around them with new abilities. Oh yes, they do that. If you're a parent, you know this. It's like suddenly your kid knows how to do this. Suddenly your kid grabs for something, that it never stood up and grabbed for before. Suddenly it tries to climb stairs, They will find how to do things pretty quick if they're interested. Milestones of motor development. Motor development is marked by a series of milestones, achievements that develop systematically each newly mastered ability, preparing a baby to tackle the next. Babies first learn simple skills and then combine them into increasingly complex systems of actions, which permit a wider or more precise range of movement and more effective control of the environment. In developing the precision grasp, for example, the infant first tries to pick things up with the whole hand, fingers closing against the palm. Later, the baby masters the pincher grasp, in which thumb and index finger meet at the tips to form a circle, making it possible to pick up tiny objects. In learning to walk, an infant first gains control of separate movements of the arms, legs, and feet before putting these movements together to take that momentous first step. So all that little silly stuff they're doing, they're reaching, grabbing, getting their body twist this way and that, sitting up, sitting on the legs, scooting on their booty or crawling, is all in preparation for them to rise up and start walking one day. The Denver Development Screening Test is used to chart normal progress between the ages of 1 month and 6 years and to identify children who are not developing normally. The test measures gross motor skills, those using large muscles such as rolling over and catching a ball, and fine motor skills using small muscles such as grasping a rattle and copying a circle. It also assesses language development and personality and social development, such as smiling spontaneously and dressing without help. The newest edition, the Denver 2 scale, includes revised norms. So your pediatrician usually does this, and some parents worry, hey, my kid's not doing this yet, and the book says it should be doing this by this age. Don't freak out. Every kid's different. Not all kids start talking at a certain age. Not all kids start walking at a certain age. All of them are different. If you have concerns, of course, ask your pediatrician. But don't get hung up on, a table that says they should be doing this by this age. Or, in a book, they should be doing this because they're all different. Some start earlier, some start later, and then make up for that. So you can't judge your kid by a book. So that's the thing there. Lifting and holding up the head from a prone position, crawling along the floor to reach something enticing, such as a furry cat's tail, and walking well enough to push a doll carriage are important early milestones of motor development. So all that play is helping them to learn and grow and, develop as a person. Head control. At birth, most infants can turn their heads from side to side while lying on their backs. While lying chest down, many can lift their heads enough to turn them. Within the first 2 to 3 months, they lift their heads higher and higher, sometimes to the point where they lose their balance and roll over on their backs. By 4 months of age, almost all infants can keep their heads erect while being held or supported in a sitting position. And of course, that's important because you need those neck muscles to hold your head up, every day of your life. You can't be flopping around, every day of your life. You have a hard time doing things that way, wouldn't you? Hand control. Babies are born with a grasping reflex. If the palms of an infant's hand is stroked, the hand closes tightly. At about 3.5 months, most infants can grasp an object of moderate size, such as a rattle, but have trouble holding a small object. Next, they begin to grasp objects with one hand and transfer them to the other, and then to hold, but not pick up, small objects. Sometime between 7 and 11 months, their hands become coordinated enough to pick up a tiny object, such as a pea, using the pincher grasp. But again, remember, tiny objects are choking hazards, so, they shouldn't be picking up tiny objects except pieces of food. The baby can hold a tower of 2 cubes, build a tower of 2 cubes. A few months after the 3rd birthday, the average toddler can copy a circle fairly well. And I started my kids at that. When the other bigger kids were doing it homework, I had a toddler and I'd give it a sheet of paper and I'd say, see if you can do this. And I'd draw a circle and a line, a circle and a line. And the 3-year-old, could do circle and a line, pretty easily. So that is a good start, to give the child the ability to draw when they get into kindergarten or Head Start or wherever, letters, because all letters come from lines and circles. So if you can start that 3-year-old, at home, if they don't go to Head Start or preschool or whatever, giving them a piece of paper and draw a circle and a line. And then when they can get that perfect, then you can just start on the alphabet. Draw this. And they can get that and draw the A, draw the B. And you can teach this kid this, 10 minutes a day. And this kid will be ready for school and okay, Now I had one that he was doing that. But he also had dysgraphia. And we didn't know that till he got into the classroom. And he was saying that's a this letter, that's a that letter, and that was not right. This is this letter, and it was turned upside down. And so after doing that for a year and a half or so, I said, hey, his brother has some problems. Maybe he has similar problems. Why don't we get him tested? And they're like, oh, well, okay. Don't know why I had to be mom to suggest that. I figured the teacher would have picked up on that with these marks on the paper she keeps giving. But, maybe that's just me. And so, yeah, he got tested and they said, oh, yeah, he has dysgraphia, a specific learning disability. He's not only reading things backwards, like dyslexia, he's reading things upside down as well. So that's a problem. And, so they got some people to work with him. And, he's a pretty successful guy now. So, again, those interventions, folks, if there's a problem, solve it. Do the best you can. Locomotion. After 3 months, the average infant begins to roll over deliberately, rather than accidentally as before. First from front to back, and then from back to front. The average baby can sit without support by 6 months of age. The average baby. Now, don't freak out if your baby can't sit up at 6 months of age, because they're all different. And can assume a sitting position without help about 2.5 months later. So on average, remember we talked about in psychology, there's no such thing as normal, there's averages. Average milestone of motor development. Don't freak out if your kid's different. Good gosh. Rolling over usually happens at about 3 months for 50% of the kids, and at 5 months for 90% of the kids. So your kid might be early bloomer, late bloomer. Don't freak out about it. Grasping a rattle at 3 months to 4 months. Sitting without support, 5 months to 6 months. Standing while holding on, 7 months to 8 months. Grasping with the thumb and the finger, 8 months to 10 months. Standing alone well, 11 months to 13 months. Walking well, 12 months to 14 months. Building a tower of 2 blocks, 14 months to 20 months. Walking up steps, 16 months to 21 months. Jumping in place, 16 months to 21 months. Copying a circle, 23 months to 2 years. And this is, again, the average. So, like I said, if your baby's behind or, even too soon, some people freak out that they shouldn't be doing that this soon. But each kid is different. So, again, the crawling is the first locomotion that your child is going to experience. Now, some kids will sit up and then scooch with their legs and move on their butt. But most kids crawl down on all fours. And that's going to get them ready for everything else that they're going to do in their life as far as locomotion goes. How motor development occurs, maturation in context. The sequence just described was traditionally thought to be genetically programmed, a largely automatic, preordained series of steps directed by the maturing brain. Today, many developmental scientists consider this view too simplistic. Instead, according to Esther Thelen, motor development is a continuous process of interaction between baby and the environment. So again, the more experiences that the baby has, the faster they're going to learn and grow. That's just a fact of life. Now, you don't want to overstimulate the kid to the point where he's, but you can kind of include the kid in what you're doing. And you can teach the kid. You can take specific moments of time out, or just a day. With one of my kids, we had this day. Because he felt like left out, so we had just his day. Where I was just doing things with him, and Grandma had the other kids. So, sometime you're gonna have to do that kid. Now, a lot of people carried their kids with them the whole time. The kid would interact with things and do things. And then when the kid was big enough to walk and when to get down by themselves, that's when that stopped. And so these children learned the day-to-day activities of their mother by watching and experiencing them. And that got them ready for the life that they were going to live. And it's not so much a thing anymore because we're busy and we're, doing things. And so we put the kid in the crib or the playpen or whatever, put the TV on and let them watch TV, and if you're going to do that, make sure it's educational TV, make sure you're teaching them something good and not some crap about, fighting and, fantasy things that, do encourage imagination sometimes, but can also lead to behaviors you don't necessarily want in your home. And that's where we're going to stop. And I hope this helps you to figure out a little bit more of why you do what you do. Until next time.